Greetings, welcome to the FIATech webinar. I'm Faith Younghands, Project Manager at FIATech. I also look after the planning and design and the information management parts of the FIATech Capital Projects Technology Roadmap. On behalf of all of us at FIATech, I'd like to thank you today for joining us for the Exploring Piping Management Through Project Information Flow, or PIF, project webinar. And today we have an hour set aside to learn from Chehade Kassouf about this new FIATech project that is progressing advancement of piping data exchanges, and it's open to FIATech members. And before I introduce Chehade, I'd like to remind you that FIATech is a member-based organization, and our objective is to accelerate the deployment of technology in the capital projects industry. We do have over 65 member companies, and we welcome new members. So if you're interested in joining, or you'd like more information, or you have an idea for a future webinar, please send me an email at faith, F-A-I-T-H, @fiatech.org. And I'd like to welcome and introduce our speaker today, Chehade Kassouf. Chehade has the perfect background as our PIF project leader. He's a mechanical engineer with 15 years experience in the oil and gas industry at an EPC, and he's worked as a site engineer in equipment erection, as well as a piping engineer for both a fabrication and erection. He's also worked as an automation engineer, responsible for data interfaces with engineering procurement partners, and he was part of the team that founded the CCC Design Division. He's also worked as a controls manager in several mega projects, working with look ahead and simulation using 3D planning. He is currently the technical manager marketing for CCT, which is the CCC's software arm. Thank you very much, Chehade. Go ahead.
Okay. Greeting, everybody. I would like to start basically this webinar by elaborating what was achieved so far in the PIF project, and then later we're going to go further in detail what we are planning to do in the future basically, and whether it is possible to achieve the so-called automated data exchange between the different phases of the EPC project or not. We would like to start with a safety moment. I don't know if the weather is the same over there, but here basically it's extremely important to have a jacket always around because the changes in temperature is quite high, and it might cause some problem to people who are not aware. Okay. Now, basically, I work currently at Computer Communication Technology, which is a leading provider of engineering information management and project control solutions. Now, the reason why we decided to go and explore the PIF project, whenever we looked at whether in FIATech or any other organization, we have seen that there are lots of interest in the design, in the operation, but the three different parts, which are fabrication, installation, and testing, did not really have such focus. So this is why we wanted to elaborate further in this one. Now, for us, a logical workflow would be we receive the piping data from the 3D model or from the 3D authoring tool. We will detail it using detailing software. After this detailing is done, we would like to have this information back into a data repository so that the spool detail and the weld details are available for fabrication. And then the fabrication by themselves could send this back to construction. And when all of the construction job is done, we should be able to send it back to the data repository so that it will be available for the handover and testing team. When we can achieve this kind of data exchange, we should be able to send the data back into the 3D model, which will be enriched with all the quality control, the construction, and the procurement detail which was grasped or harnessed during the project construction lifecycle. Now, why this is quite important for us? Basically, if we work in any piping intensive project, we always see that there are delays which happen during the piping installation. And if you ask the installation guys, they'll tell you, look, we are not receiving the spool on time. If you go to the fabrication guys, they will tell you, look, they are not sending us the material on time. And when you want to go and see what is the source of this problem, you always notice that the design firm normally, because they are pressurized to produce drawing, they start sending the isometric in a balloon-like approach, like you will receive 5,000 in one time. And then the detailing team, regardless of how big they are, they will become the bottleneck. Now, what we have found as well is if you want to do proper planning in which you can do your 3 months look ahead and 3 week look ahead, which is quite detailed and accurate, you're going to need to do your detailing prior to going with the assumption like 60% is fabrication and 40% is erection. So consequently, if this detailing is done, your look ahead will be more accurate and efficiencies can increase. I just put a note on the bottom based on the CII that 25 to 40% increase in the efficiency is achieved if you have these kind of look aheads available. Now, what is basically the original objective of the PIF project? At the beginning, we wanted to see the ISO 15926 and this whole data exchange theory. If we want to implement it really in one single project, can we get there? Are we in a position with the current tool available to be able to get the smooth data exchange between the different data? This was the original scope. So consequently, we have found that there are some missing parts in order to achieve this full cycle. And we decided to fill in those gaps so that we make sure that this cycle is done. And this is where the idea came that we want to define the requirement of piping data required in construction. Now, for us to be able to show the importance of this information, also we decided to put a demo, which was basically presented in the FIATEC meeting. And this demo to show that really such data exchange is achievable. Now, for the cost and schedule saving achieved, this was the main objective. We were able to find some saving achieved, but it was quite difficult to quantify it because, you know, no single project is similar to the other. We have seen some improvement in, let's say, efficiency based on the company's norm, but still this was not enough to come up and put, let's say, a figure, I have achieved so and so saving. Now, if you want to explore the, let's say, the data piping world by itself, we can see that currently in the market, most of the 3D authoring tools, they use the IsoGen to produce the isometric or the 2D isometric drawing out of the 3D model. And with those exported data, there is always a file format called piping component file, PCF, which is a text file and contain the majority of the data required to understand what is meant by this isometric. On the other hand, we have seen that ISO 15926 has covered quite a lot of the requirement in order to achieve this kind of data exchange. However, none of those two have the full picture. So in other words, there are some, let's say, modification or expansion, whether on the PCF or on the ISO 15926, to be able to achieve these data exchanges. Now, as a deliverable, we wanted to provide list of required data exchange and attribute to reflect in piping construction. They will come in the next slide. What do we mean by these? We want to modify or extend the current data exchange format, whether we want to go with the PCF or whether we want to go with another format which is compliant with ISO 15926, but either or a modification or extension is really required. We want to define the piping specification, which is normally it's the heart of the piping definitions. And then we want to show some demo which show the full cycle. And at the end of this project, we should be able to produce a best practice document on data exchange tools which could be used in pipe. Now, this is basically a piping data flow. If you notice, this is how things happen nowadays. You receive the 3D model. 3D model produce for you a 2D isometric, which is normally for construction. Now, this 2D isometric is transmitted via official EDMS transmitter to the contractor. Now, the contractor will take these drawings, and then he will generate out of it two types of drawing. One is called fabrication isometric, and the other is erection isometric. And then along with these, normally the construction will rely on material spec and line list and support standard to be embedded within these drawings, so that whenever it reaches site, there is no room for confusion when the fabricator needs to fabricate it. And definitely the result of all of these need to go into an ERP system, which will decide what material needs to be issued and how it can be followed, and the quality control data and so on. This is how the, let's say, the typical data flow is being done nowadays. Now, in this data flow, there is a quite big importance on the transmittal, because this is basically what officializes the data transfer between the design and the construction. Without this, there are no, let's say, tangible or legal document which says that, okay, the design has provided the construction these information. Now, if you want to define the requirement for piping, we will see that we need piping specification, we need geometric standard. In other words, whenever I say, let's say, a 90-degree elbow, I need to know what standard it follows. Is it ASME 16.9? Is it DIN? I don't know. Is it GOST, which is the Russian standard? I need to know what geometric standard it follows. And when it comes to its material, what material it is made of. Also, I need to know what is the material standard which is based. And the other item are the drafting rules and symbol. Like if I want to draw it or to sketch it, what kind of sketch I need to provide for this piece of piping so that it is legible by the party who need to modify or to prepare the fabrication and the installation. Now, this is a detailed piping workflow. This is basically how we do it in CCC. If you notice, we receive the isometric, we do the breakup, we check the spool. All of this is done whenever we are preparing the drawing. Then we go to the material warehouse, we reserve the material, and then we do the proper nesting and so on. And then we provide all of these into the welding team. Whenever they weld it, there are some QC checks, NDE requirements which are achieved, and after that it goes to the painting. After it gets painted, it will go back and wait in a laydown area so that whenever it's required on site, it will go to the site. When it goes to site, it gets erected, welded, and then it is tested. And by this, we have concluded basically the whole workflow. What's important is at every step of those, we need to be able to track or trace what's happening to our spool, especially when it comes to material and material traceability and which welder weld this weld and so on. Now here I just showed some of the parameters which are of importance in the piping industry. For instance, if you look at the BOQ measurement units, you can see that there are some terms which are used only in this industry, like inch dia, inch meter, surface area, and so on. All of these are a way of measuring whether progress or requirements for testing, like inch meter is a good indicator of how much testing you're going to be needing, or inch dia is a good indicator to know how much welding you're going to be needing. Surface area is good for painting, and so on. Also, there are different types of spool. I just listed some of them, like the fabrication spool, the field spool, the field run, and field material, block sets, and so on. Now, these are many of the parameters that we believe should be available within the data that is being transferred from and to construction. Now, this is a typical spool drawing. if you can see, these are quite important for the shop to be able to fabricate this. We can see we have material information, we have quality information like what welding procedure specification is required, what are the non-destructive testing required or examination. If I'm putting any symbol within this drawing, what is the symbol convention, revision information, who did the revision, who checked it, and so on. And also, I need to know for every one of those schools, what are the BOQ information or bill of quantities, the name of this drawing, what is the parent school or from where it came, all of these, plus some schematics. And, you know, like this one, the CS, it's important for the fabrication because this is how they segregate their items. Like, okay, carbon steel, put them, send them to the carbon steel shop, while stainless steel go to a different shop so that there are no contamination and so on. Now, this is what goes to the site whenever they install. If you notice, this is basically is a collection of the fabrication drawing. They are all put together in one drawing, and there are virtually the same information with the addition of the field weld tables, which we can see here. And the rest, you can see also process information are available or put in this drawing, because normally this drawing is what goes into the test package, and whenever they are doing some testing, they rely on these information to know what kind of testing, what pressure, and what are the different process information required. Okay. Now, the source of information. This is important to know from where all of these information come from. For example, the material data. If we look at the place or the boxes where the material data is, normally the weight, the actual cut lengths, and the outer surface is not present in the exported 3D model. In other words, we rarely find that whenever you receive the electronic data from the designer, he put for you the weight or the actual cut lengths. So what normally we do as a construction team, we go and take their piping specification, and we take each and every one of those pieces to add the weight per unit. Like if it is a pipe, weight, let's say, per meter. If it is an elbow, what's the weight of this elbow, and the different information. It really takes lots of effort from the construction team, knowing that the design team already have all of this data. So we have to ensure that this data goes to and from. Also, there are some weld information. Now, the weld information, specifically the welding procedure specification and what are the testing, these are some rule-based. Like you have the specification of the quality control. He tell you if size is so and so, if material is so, use this WPS and so on. So we need also to apply this kind of rule-based to populate this kind of information. The process information, which are the line list data, normally it comes from the 3D model, but it is always the case that the 3D firm, whenever there are some modification to the line list, they do not implement it back into the 3D model, and even if they implement it, they would not revise the drawing and resend it to you. So we have also to be able to plug these kind of information as we are doing the process. Pipe support data, it's also the same story. Sometimes they just send us a unique ID. Will tell you, okay, put support number 1 in this location, and later on they send us some standard to tell us, 1 means it is a trunnion of this size and so on. And also we need to be able to know what are this information and plug it into the drawing. This is a testing information. This is normally what goes into the test pack. We need the welding report. So mostly these data are produced by the construction team, and it is important to send this back into the model, because later on when we reach the operation and maintenance, if there is any issue, let's say with, I don't know, with weld, we need to know what welder did this weld to know if we need to check the rest of his welds, or maybe the electrode he's using was, I don't know, defective, and we need to check where it was used elsewhere. So these kind of information need really to go back to the model. Now, example of data exchange attribute needed. Okay. Currently, I'm just giving you an example to show you what we have and what we are planning to achieve. Currently, if you look at any drawing which come from the 3D designer, you will see a code which represents the material. And underneath this code, you will see a description. Now, as a human, if I read this description, this is more than enough for me to be able to understand what material they are talking about. However, if for any reason in this description they just change the order of the text, let's say if they want to say pipe, let's say LTCS, I don't know, maybe B333, which is the material. If they just put B333 before the LTCS, in this case, as a human, I can understand it, but as a machine, it will find difficulty to be able to decipher this kind of description. So for us, what's important is when this data come from the design into the construction, it should have a material type which is linked to some library that everybody understands what type of material is this. It should be related to some geometric standard so that the second I look at this standard, I know exactly what are the dimension and the curvature of a certain piece. And also I need to know what is the component type. Is it an elbow, is it a T, and so on. These kind of information are what's required, but currently what's received from the designer are the first one which I mentioned. This is another one also. We can see like the weld type, weld category, weld number. This is what we have. While from our side, we need is weld type, category, combination. What are the PC requirements? These are nothing but samples to show you what we are receiving, what's important for us. Here, for example, when it comes to the 2D/3D shape, we notice many times that the 3D authoring tools allow the designer to come up with any type of shape they want. They might combine, let's say, I don't know, maybe a valve with a nipple with another plug, and they call it, they give it a certain ID. When it comes to the construction, it will be very difficult from, let's say, data exchange perspective to know what they mean by this. Somebody will have to go and visually look at this kind of shape to understand what they mean. So, what do we need in PIF basically? If fabrication get what they want, they will send what they should. If installation get what they need, they can send what they should. We need a standard for this process. Now, basically, when we went to the meeting in Boulder, Colorado, what we did in this meeting is we showed a real demo. And in this demo, basically, we showed that it is possible to do the whole data transfer. And in this demo, basically, we showed how we receive the data from the 3D model, how we detail it. After we do the detailing, how we send this data back to the ERP system, back to the 3D model, and we run major planning and 3 weeks look ahead approach based on this data because the data is already there. Okay. Now I'm ready for questions.
So Chehade, we've got a little bit of time. I don't know if you want to show any of that demo. Maybe you don't have it open, huh?
We can. It's easily shown. Yalla, give me a sec.
Okay. Yeah, I think that might be good.
All right. So, show desktop. So, now I'm opening a 2D detailing system. This is basically developed by our company, CCT. It's called Solinas. Okay. In this, I'm going to basically be loading a PCF. Okay, now I can see that this PCF, he already have detailed the drawing into its different constituent. And then I'm going to be exporting this PCF into the C3DX format, which can be read by our 3D system. I will also export the data part, which is this one. Okay. Now, after this exporting is done, I will show you how the data would look like, basically. So, we can see that in this sample, we will have all the detail of the ISO plus some summaries. We can see also all the detail of the schools with some summary like the BOQ data, number of sheets, where it belongs. I can know also what is this isometric made of, like, I don't know, maybe this school is made of a flange and so on, with the full detail of these data. I can as well see the weld table, which will show me the different welds with their unique numbers, and between what and what kind of class it is, what kind of welding procedure it is required, and so on. Okay. Now, I will also show you the 3D model version of all of these. So basically, I'm opening now a C3D Interactive, which is a viewer also developed by CCT company. Okay, I will create a new project. Let's call it Test 5. And then I will load the C3DX, which I have exported. This is a drawing that was detailed. The important part here, I mean, every viewer can show this one, but the importance is the data which came along with it. So here I can see that I have the parent is an isometric, which is made of spools. Now those spools are here. I have their unique ID, and all the detail that I have seen in the data are here. And then if I go further and expand the spool, I can see that it is made of components and welds. And I can know each and every component, what is it made of, and definitely I have the full detail of component. Now, what does this mean in terms of, let's say, project control? This is at the end, this is our aim, is to be able to have a proper project control and proper data flow. We have a certain example. This is also what I showed in the FIATech. So I will open some ready-made examples. So let us open the word packaging, for example. Here, because the data is available for me, it will show you what kind of manipulation I can do in, like, whoever is familiar with the workplace planning and the work packaging approach. You see here that in this, for example, specific project, I decided to prepare a number of work packaging, of work packages, I mean, and this is there. Okay. Now this area is made of 3 work packages. I will open one of them. I can see that these work packages are made of piping items, which are the constituent of my work package. And it's made also on non-piping item, however, which my work package depends on, which are the structure and foundation which are supporting those pipes. And also this work package is made of what we call here front-end loading items. So here, for example, before I start this job, I have to ensure that the barricade, for example, is done because it required excavation. This is from a safety perspective. Let me group them a bit. From a construction perspective, I have to ensure, for example, that my steel are there. If it is a very cold area, my winterization is there. Scaffolding, is it done or not? So all of these check boxes are actually being tied with this specific work package. I would have never achieved this one if I did not have really the detailed spooling data which are coming from this exchange, basically. We will show another sample. Face, can you still hear me well?
Excellent, Chehade. It looks great.
All right, because it's showing me the reduced experience. Okay, this is another sample here. Which will show us another application of having such data available. Now this sample basically will show us the status of the detailing office. How is he doing when it comes to detailing? And whether what he is detailing have already material or not. This is basically a power plant that we had to do the detailing. Like the detailing was not done by the fabrication, it was done by a separate office. And we wanted to see if whatever is detailed really have material to be able to erect it or not.
That's actually one of the questions, Chehade. Somebody asked, the fabrication piping spools are developed in the 3D model? Fabrication piping spools are developed in the 3D model?
No, they're actually developed in 2D software like SpoolGen or Sopolinas. Okay, because this is how the, let's say, the industry is used to. This is the issue. Later on, it's preferable to have it done via some mobile approach or some mobile system. But now we are looking to have the data available, and then later we'll decide what tools to be used to be able to define those kind of limits. So here, for example, in this drawing or in this view, I can see whatever is blue, it has a material which was reserved for. This is, I'm talking about the fabrication part. And whatever is red, it means the material is not there. This is how I was able to achieve this one, because I know what every spool is made of, and I made some patching or cross-reference with the material data which is available for me. This is basically the 3 samples that I wanted to share with you about the importance of having this data available with us. Okay, Faith, I'm open for questions.
Okay, so yeah, so the question, I don't know if I read it correctly, was what if the fabrication piping spools are developed in the 3D model? Does that impact your data flow diagram?
No, actually, it will improve it.
Okay. Do you want to say any more about it? Anything else about it?
Now, basically, if it is normally developed in the 3D model, okay, the important part is to agree on the mechanism how to receive the data. As long as we receive these kind of information, which I summarized here, if we receive all of these data along with the information which was provided, so it will make our life much easier.
Okay, good.
Like if we receive, yeah, the type of spools and the welds and type of welds with a proper definition so that there is no confusion at site, this will make our life much easier.
Okay, good. So another question, can you say more about the format used? Is the C3DX format based on ISO 15926? Is it based on the XM plant?
Now, basically, the C3DX is based on XM plant schema, which allow us to have the different geometry with basically the data attached with it. Now, having it linked to ISO 15926, this is not achieved through all the different classes because, as I mentioned, we are able to find all the classes within the RDL, and this is what we are planning to do in this project to ensure to have them in our at least sandbox in order to make the full link. But basically, the format, I mean, we can show it. Let me see. This is C3DX. Is an XML based, and which basically will have the hierarchy. So we start with the top one is the ISO, then we will go with the hierarchy to reach the spool, and the spool is made of different objects, which are the piping component. Now these piping components are made of properties and geometry. So here, what we see here is the geometry which allows the 3D model to draw them, and on top are the different property. If you notice, it's extremely rich with property, like virtually any property that you might imagine required by the construction is already available here.
Okay, so another question, Chehade. What minimum hardware configuration is required as far as memory or 32-bit, 64-bit? And where are the limits for import? For example, the number of components or number of PCF files?
Okay. Now, there are two parts, if you notice. There is the detailing part, which is based on AutoCAD. So whatever is required for AutoCAD 2013 and above, and 2014 now, is required as a minimum hardware required for the Solimas. This is when we are talking about the detailing part. Now, for the viewing part, basically, which is the C3DX, this is a database-based entity. The hardware, actually, the bulk of the hardware is in the graphic card. So for me, like the machine I'm using now is an Apple MacBook Air, which has solid-state drive. That's what's make it capable of loading these kind of models. However, it is recommended to have a machine which have GeForce Quadro in order to be able to load these kind of model and be able to navigate fast in that. Now, when it comes to importing data, so far we did not see any limit. Whatever the Microsoft SQL Server can withstand, we can import. Because this importing, all what it does, it reads the file and plug it into the database later on for view.
Okay, thank you, Chehade.
There's one item I need to add. Yeah, just for this specific requirement. There is a capability within this system which we call it the volumetric approach. Now I'm going to draw just a small volume. And this volume, I can ask this system, okay, take the content or whatever is inside this volume, whether loaded or not, and make a model out of them. So in this case, even if there is some hardware limitation, you can still use this approach to splice your model into smaller pieces, and you can load it.
Okay, you ready for another question?
Yeah.
Okay, there is a lot of data being managed. When and how is this data checked and verified in the process?
Okay, now I will tell you how we are doing it. How it should be done, basically, we did not think about it a lot. Now, basically, whenever the data is being detailed by Solinas, which is at this stage, here, whenever this, at this stage, the breakup is done, and the data is being exported, we normally have a checker who randomly would go check, and at the same time we have some small routines which go cross-check the 3D database with the output of the detailing database. Now, the output of the detailing database and the 3D database, we can check them based on the grouping. Like in this ISO, how many linear meter of pipe I have, I compare it with what I have in my detailed drawing. However, the weld data and the remaining data, normally this is being looked at by what we call piping checkers, who ensure that this kind of data is done. But normally, we do this at the beginning of the process to ensure that all the hiccups are being taken care of. But later on, it will be just random check, because whenever the flow starts working correctly, the amount of error becomes minimized.
Okay,
I'm ready for the next.
Okay, so next question. I've heard that some companies are not using piping isometrics. Are you looking at that?
Yes, actually, it's a dream, because if you notice in Solinas, I don't know who are familiar with the piping industry. Normally, the availability of isometrics, especially when the companies or the detailing, the designer company decide to cut the isometric at the middle of a pipe rack, for example, they are causing for us a really big hassle, because if we want to follow their isometric limit, we will end up with additional cuts and redundant welds because of this this limit in the middle of the pipe rack. And if we don't want to follow their limit, it means we will have to end up transferring material from one ISO to the other, so that we add, let's say, the pressure on the detailing office, however, minimize the amount of cut and weld, which is much more expensive than having to do it on a piece of drawing. So this is really a hassle for us. If we can go with an approach that does not take the isometric into consideration, it will be, let's say, from a construction perspective, way better. But to achieve there, I mean, we are talking about changing the whole mentality of the design firm, because I believe the way they do the design is based on these engineering area, and that's how they assign it, whether to subcontractors or to designer and so on. It should start from there.
Okay, thank you. Another question, Chehade. What about global work sharing?
The global what?
Global work sharing? So in other words, I think if there's other people in other parts of the world that are working on one project together, like with joint ventures?
Yeah. Now, basically, for us, these kind, let's say, whether the Solinas application, it can read these data from a file perspective and store it in a file in files. The reason why we decided to go by the file and not to go by the, let's say, the live data transfer, similar to iRing Tools approach, is till now, you know, the electronic data management transmitter is of high importance, especially for construction. Like if somebody go and ask you, look, I send you a revision on this piece, and or he told me, look, this ISO that you have worked on, or this piece of piping that you worked on was not approved for issuance. The only way for me to trace it is via this electronic data management system transmittal or submittal, because the date of this one will dictate whether this was issued for construction or not, can I use it or not. Now, for this one, as you notice, we have files, and as long as those files are there, whether you have one office or 10 offices, we rely basically on the electronic data management system to take care of this. We read the file, we generate the file, but transmitting those files so that they become usable or useful by somebody else, they should be attached to a certain transmitter. And I don't know if you noticed, while we were in the members meeting, we were talking with a gentleman who mentioned this hash approach, that you can encapsulate your text file with a hash, and in this case you can guarantee if somebody changes it, you will be notified, or he cannot change it without breaking this hash, and accordingly it will be more reliable.
Okay, thank you, Chehade. Another question? So I think in the beginning when we had one of our objectives of the project was to approximate the cost and schedule savings on the project using the best exchange tools and best practices. So the question is, how do you plan to approach this?
Now, basically, what we did as company, as CCC, we had actually 3 main projects in which this kind of approach was utilized. Now, we did a data transfer from the engineering to the construction and then back to the 3D model, and this kind of information was used to plan and ensure that the quality control is done and so on. And in these three projects, basically one was in Kazakhstan and the other 2 were in the United Arab Emirates. In these 3 projects, we have achieved a result which were better, let's say, than similar project within the company. I mean, in the one in Kazakhstan, we have achieved 1.2, in other words, 20% improvement in productivity. Now, I cannot say that 100% the reason is because of this data exchange or transfer, but what's very high in importance is having these kind of data transfer. It made the life of the site engineer or the guy who prepared the 3 weeks look ahead or the material management team and so on much easier, because all the information were available, you know, at their fingertips, and it was actually classified properly. Like, if you want to know this specific area in the project, at this elevation of the pipe rack, how many welds you need, how many pipe, how many paint, square meterage of painting, and so on, you were able to grasp this information because it was transported back to the 3D model.
Okay, thank you, Chehade. Just a couple more questions. Who is working on this project?
Currently, basically, from CCC, myself and I have 2 colleagues within the team, and we have from Numenum, Mr. Adrian, and you yourself, Faith.
Yep, and then the other companies, Intergraph, and then the other work on it, and we also have interest from Bechtel, Aviva, Bentley, and Arriva. So, okay, I think one last question that I had is there a project schedule?
Project schedule? No, not really.
Not yet.
We will prepare it eventually.
Okay, I think that was all the questions, Chehade. Nice job.
Okay.
So thank you, everybody. Is there anything else you want to do, Chehade?
No, I'm good. Thanks a lot for everyone who attended. I really appreciate it, and I hope that we provided the information and we will receive your support in achieving this project or the goal of this project.
Yep, and we're putting together the team and the schedule and the project plan. So if you are interested, you can contact me or Chehade and help us out and work on the project. And thank you very much. And also, Chehade, people are telling you thank you on the questions too.
Okay.
So we'll come to the conclusion. Thanks everybody for being here. We did make a recording and it will be on the webinar archives on the FIATech website within the next few days. So thank you again, Chehade, for talking about the Piping Information Flow project, which is kicking off. Contact me if you have any other ideas for future webinars, and have a great day. Thanks, Chehade.
Thank you.
All right.
Bye.
Bye everybody.